Hello everyone, and welcome back to Budi Network Academy. I am Budi, and in today's video, we are going to learn about one of the most important concepts in computer networking, the OSI model. If you have been following our previous videos, we have already talked about networks, switches, routers, IP addresses, and MAC addresses. Today, we are going to bring many of these concepts together and see where they fit within the OSI model. By the end of this video, you will understand the 7 layers of the OSI model and the basic role of each layer. Let's get started. Computer networks can be very complicated. There are cables, switches, routers, IP addresses, applications, protocols, and many other technologies working together. So, how can we understand everything that's happening when two devices communicate? This is where the OSI model helps us. The OSI model divides network communication into 7 different layers. Each layer has a specific role. This makes networking easier to understand, design, troubleshoot, and explain. Think of it as a way to break a complicated process into smaller and easier pieces. So, what exactly is the OSI model? OSI stands for Open Systems Interconnection. It is a conceptual reference model that helps us understand how devices communicate over a network. The model has 7 layers, and each layer represents a different part of network communication. It's important to understand that the OSI model is mainly a reference model for understanding networking. Real-world networking technologies don't always fit perfectly into just one OSI layer, but the model gives network engineers a common way to describe and troubleshoot communication. Now, let's look at the 7 layers of the OSI model. Starting from the bottom, we have Layer 1 physical, Layer 2 data link, Layer 3 network, Layer 4 transport, Layer 5 session, Layer 6 presentation, and finally Layer 7 application. Each layer has a different responsibility. In the next slides, we will look at these layers and understand what each one does. Let's start with layer 1, the physical layer. As the name suggests, this layer deals with the physical transmission of data. It includes things such as Ethernet cables, fiber optic cables, connectors, electrical signals, light signals, and radio signals. The physical layer is responsible for transmitting raw bits across the physical medium. For example, when data travels through an Ethernet cable or through a fiber optic cable, layer 1 is involved. A simple way to remember layer 1 is physical layer equals cables, signals, and bits. Next, we have layer 2, the data link layer. This layer is responsible for communication within the local network. One important concept here is the MAC address. Ethernet frames also operate at this layer, and this is where we can connect what we learned in our previous videos. Remember our video about the switches? A switch primarily operates at layer 2 and uses MAC addresses to make forwarding decisions. So, a simple way to remember layer 2 is data link, MAC addresses, Ethernet, switch. Now, let's move to layer 3, the network layer. This layer is responsible for logical addressing and routing. One of the most important protocols associated with this layer is IP. And this is where our previous video about IP addresses connects directly. Routers operate primarily at layer 3 and use IP addressing to make routing decisions. So remember, layer 3, IP addresses, routing, router. This is the layer that allows traffic to move between different networks. Now let's look briefly at the upper 4 layers. Layer 4 is the transport layer. It provides communication between applications and includes protocols such as TCP and UDP. Layer 5 in the session layer. It helps establish, manage, and terminate communication sessions. Layer 6 is the presentation layer. It deals with how data is represented, including things such as formatting, encryption, and compression. And finally, layer 7 is the application layer. This is the layer closest to the applications that users interact with. Examples include network services and protocols such as HTTP, DNS, and DHCP. For this beginner's guide, we don't need to memorize every detail of these 4 layers yet. The important thing is to understand their general purpose. Let's put everything together with a simple real-world example. Imagine you are using your computer to open a website. At the physical layer, data is transmitted through cables, fiber, or wireless signals. At layer 2, Ethernet and MAC addresses are used for communication on the local network. At layer 3, IP addresses and routing help move the traffic between networks. At layer 4, protocols such as TCP or UDP handle transport between applications, and at the upper layers, the application data is prepared and used by the application you are working with. So the OSI model gives us a way to understand what's happening at different stages of network communication. Before we finish, let's quickly review what we have learned today. The OSI model stands for Open System Interconnection. It is a conceptual reference model that divides network communication into 7 layers. Layer 1, physical, cables, signals, and bits. Layer 2, data link, MAC addresses, Ethernet, and switching. Layer 3, network, IP addresses, and routing. Layer 4, transport, TCP and UDP. Layer 5, session, managing communication sessions. Layer 6 presentation, data representation, encryption and compression. Layer 7 application, network services and application communication. Understanding these 7 layers gives you a strong foundation for learning more advanced networking concepts. For watching this video, I hope you now have a better understanding of the OSI model and the 7 layers of network communication. If you have followed the previous episodes, you can now see how many of the concepts we have learned fit together. Switch, layer 2, MAC address, router, layer 3, IP address. And this is just the beginning of our networking journey. If you found this video helpful, please like, comment, and subscribe to support Budi Network Academy. And here's today's question. Which OSI layer does a network switch primarily operate at? Let me know your answer in the comment. This video also completes our Networking Fundamentals Beginner's Guides chapter. In our next episode, we will start a new chapter and move into intermediate networking. Until then, learn, troubleshoot, connect. I am Budi. I will see you in the next video.